So we've been talking about adding polynomials, subtracting polynomials, multiplying polynomials. So now we're going to go one step farther and we're going to solve equations that look like polynomials, that are set up kind of like our polynomials that we were multiplying. So when we do that, we use what's called the zero product property, which is a really big fancy math word for anytime you're multiplying two things and it equals 0, one of them has to be 0. So if we look at that first example A that I have written there, and if I asked you 3 times 0, you'd be like, yes, this is the best quiz I have taken in a long time, right? 3 times 0, what do we get? 0. What if I asked you for 0 times negative 4.5? 0. What about if I made it scary and said negative 2 over 57 times 0? Still 0. What if I asked you for x times 0? A little bit trickier, but we've figured out, doesn't matter how scary the number looks, right? If we multiply it by 0, it's going to be 0. So x is just representing a number we don't know, but it doesn't matter what that number is, because if we multiply it by 0, we're going to get 0. So our zero product property tells us that anytime we're multiplying two things and the answer is 0, so anytime we multiply two things and it equals 0, one of them has to be 0. So we want to write down any time we multiply two things and they equal 0, one of them has to be 0. So in order for us to get it to equal 0, we have to multiply by 0 to begin with. They might both be 0, or just one of them can be 0, but one of them has to be 0. So anytime we multiply two things and they, I missed equals because I was talking, and they equal 0, one of them has to be 0. So no matter how scary it looks, when we have two sets of parentheses like that are multiplying and equal 0, one of the parentheses has to have a 0 inside. We could have as many sets of parentheses really as we wanted, but we need to have at least 2 because we need 2 numbers to be multiplying. But we've seen before where you can multiply 3 numbers, right? We could do 5 times 10 times 3. We can multiply as many numbers together as we want, so we could have as many sets of parentheses as we want, and we're going to solve it exactly the same way no matter how many sets of parentheses we have. But just knowing that when we have sets of parentheses multiplying and they're telling us it equals 0, one of them has to be 0. So that's going to kind of be what we're going to use in order to solve all these problems today. Before we do that, I just want to talk to you again about standard form we've already seen. Remember, standard form is when our exponents are in order from biggest to smallest. Biggest to smallest, and those are things like x squared plus 3x. So my coefficients don't matter. It's my exponents, right? I have a 2 and nothing's here, so that's really just a 1, right? So they're in order from biggest to smallest. Or I could get even fancier and say something like 5x squared minus 24x plus 7. That's still in standard form because I still have my biggest exponent, a 2, then a 1, and then there's nothing here. So it's still in order from biggest to smallest. So those are standard form. So when things are in standard form, we're not going to be able to solve them quite yet because those aren't things that are multiplying, right? We're adding and subtracting those terms together. We're going to solve things today that are being multiplied, so they're going to look like those problems that we were foiling. And when they look like problems that can be foiled, we call that factored form. So these look like FOIL problems. So those are our problems that had the two sets of parentheses right next to each other. So things like x minus 2, 3x plus 4, right? Those things that we were foiling. So we're only going to be solving those things that we were foiling today, those things that multiply together. We can also have factored form where we might only have a monomial as the first thing that we're multiplying, so they might not both be in parentheses because we only need the parentheses if we're adding and subtracting things. So we could have something that looks like this where the first term is not in parentheses just because there's nothing that we have to group with it, and that still is considered factored form. So as long as they're actually side by side and multiplying, that's what we're looking for. So once we have things that are in factored form, when we're solving them, the first thing we're going to want to do is take each set of parentheses or each factor and set them equal to 0. So step 1, set each factor equal to 0. So it's going to end up looking like the problems in the do now, where we just had things like 5x plus 2 equals 0. That will be solving. Or x minus 1 equals 0, that will be solving. So the actual equations that we're going to be solving are going to be those pretty ones from the beginning of the year that everyone feels really good about. They just look a little bit intimidating from the beginning because they're set up like FOIL problems. So once we set them equal to 0, we're going to solve each equation for x or whatever variable, because we really can use any letter that we want. So we're just going to solve each of them separately, and then those will be our answers for these problems. All right, you ready to actually see them? So if we want to solve each equation, the first one wants us to take 2x times x minus 4 equals 0 and solve for x, which looks a little bit intimidating because we've got 2 x's in there, right? It's not like we're used to. It's not where just things are adding and subtracting and we can just move them to the other side. But we're going to take this first factor and set it equal to 0. Then we're going to take the second factor and set it equal to 0. And then we're just going to solve two equations. So it's like it's giving you two problems at one time, all smushed together. So once we break it apart, I take that 2x, and all I'm going to do is say 2x equals 0, because I know if I'm multiplying two things together, one of them has to be 0 since the whole thing equals 0. And I'm also going to take x minus 4 and set it equal to 0. And then I'm just going to solve each equation, which we're really good at doing this, right? These are one-step equations for us to solve. So if I have 2x equals 0, and I want to get rid of the 2, I'm just going to divide by 2 on both sides. And I get x equals 0 divided by 2. Zero divided by 2 just gives us 0. Zero divided by any number is always going to give us 0. Yeah. The other one, I've got to add 4. When I add 4, I get x equals 4. So now my two answers for problem A are x equals 0 and x equals 4. So I'm going to get two separate answers. I should always get an answer for every number of factors that I have. So since I had 2 factors, I get 2 answers. In B, I have 2 factors, so I should get 2 answers. If I had multiple sets of parentheses, I should get an answer for each set of parentheses I have. So now if I'm going to do B, I just have to take my 2 sets of parentheses, set them both equal to 0. So I'm just going to take my first set, my x plus 3, and I'm going to say, okay, or sorry, x minus 3 equals 0. And then I'm going to take my second set and say, okay, x minus 9 equals 0. And then we're happy because these are easy for us to solve. We add 3 to both sides to get rid of the negative 3. And we get x equals 3. We add 9 to both sides to get rid of the negative 9. And we get x equals 9. So my two answers for B are 3 and 9. The trickiest this can get is like C and D. So C tells us x minus 1 all squared equals 0. But we know from doing our special products, multiplying our special products, that anytime we have x minus 1 or anything in parentheses all squared, we just really have 2 of those parentheses, right? We really just have x minus 1 times x minus 1 equals 0. So this is a special case where even though I have 2 sets of parentheses, I'm only really going to get one answer because both of my parentheses are exactly the same. So if I end up with parentheses that are the same or they're repeating like that, I'm not going to get 2 separate answers because no matter what I do, I'm going to get x minus 1 equals 0 and x minus 1 equals 0. My equations are exactly the same there, so I'm going to get the exact same answer here. So there are special cases where you will get one answer, or you might have less answers than the number of factors that you have. And that's going to happen anytime your factors are exactly the same, because I'm doing exactly the same thing to both of my equations since they're exactly the same. And I get x equals 1 and x equals 1. So it is okay for you to get the same answer as long as your factors were exactly the same. And now with D, we have 3 sets of parentheses, or we have 3 factors in there. So even though it looks a little bit scarier, looks a little bit longer, all we're going to do is take all 3 sets of parentheses and set each one equal to 0 and solve them. So you really just have 3 equations that you're solving here. Because you're going to take the first one, x plus 1 equals 0, x minus 3 equals 0 and x minus 2 equals 0. So once you set each factor equal to 0, then you just solve each one to get all of your answers. Oops. I want to subtract 1. I get x equals -1. Then I want to add 3. I get x equals 3. And I want to add 2. So because of the zero product property, anytime we have polynomials that are multiplying each other and they equal 0, we can solve them by just splitting up the factors and setting each factor equal to 0 and solving each factor individually.